We are living in the age of engineered comfort. We tell ourselves we're the smartest generation ever to exist. We have smart thermostats, foam injection, passive houses, and triple-paned windows. We're protected from the cold by science and technology that our ancestors could never have imagined. But what if that entire narrative is a lie? What if the pinnacle of insulation, the structure designed to keep you safest in the face of a brutal world-ending winter, is not new, but ancient? In 2009, something happened in Germany that forced modern engineers to humble themselves before history. At the Hessentag Festival, a specialized team tested a reconstructed wall, not Roman, not just medieval, a wall from the Bronze Age, 3,400 years old. The design was simple, built from mud, clay, and grass. The results stunned them. The thermal performance of that 3,400-year-old design met modern German building codes from 1995. Think about that. We spent millennia, billions of dollars, and built entire industries trying to achieve a standard that ancient builders mastered with materials found in their backyard. But here is the most terrifying paradox. In the thousands of years between the Bronze Age and 1995, we didn't merely forget this knowledge, we actively regressed. Our insulation technology got 4 to 6 times worse. We didn't progress, we regressed. Picture the modern catastrophe. A January blizzard hits. The temperature plunges to -40 degrees Fahrenheit. The power grid fails. Your pipes freeze solid within the first 6 hours. The thin, chemical-laden walls of your $500,000 home offer the thermal resistance of a cardboard box. Your family is facing a survival timer that counts down in hours, not days. Now picture the medieval peasant. January 1320. Outside, the same -40 degrees. No gas lines, no central furnace, no electricity. Yet he is warm. His children are safe. His water is liquid. His house endures. What primal wisdom, what ingenious physics did the medieval master builder possess that we, armed with supercomputers and chemical polymers, have utterly abandoned? What secrets are locked inside the very fabric of the earth that allowed them to cheat the grim reaper of the winter? The answer is not a single secret. It is a two-step system of radical thermal intelligence. It's the convergence of material science and brilliant physics applied to a single construction, the double-walled Wattle and Daub structure. You think you know Wattle and Daub? You think it's just mud and sticks? That is the common and potentially fatal misunderstanding. Everyone is focused on the material, the dirt, the clay. They miss the mechanism. They miss the twist. The first step is the simplest, yet the most overlooked. The second step is the genius that elevates a humble peasant hut into a self-regulating thermal fortress. But if you execute step 1 without understanding step 2, you end up with nothing but a cold, damp, moldy tomb. To fully grasp the magnitude of our modern failure, we must quantify the cost of our ignorance. Today, when you build a modern home, your insulation package, the chemically derived fiberglass bats, the petroleum-based foam boards, can easily cost you $10,000 to $20,000 for materials alone. This money feeds an industrial complex built on manufacturing, shipping, and non-renewable resources. Now consider the medieval builders' inventory. What was their equivalent cost? Zero. They needed willow branches found by the stream, clay and dirt dug from the ground beneath their feet, grass and straw collected from the fields, animal dung a byproduct of their livestock. Their thermal envelope was made of essentially free, locally sourced, renewable materials. Their house was not a consumer product. It was an extension of the earth itself. This is the central paradox we are here to solve. How did materials that cost $0 achieve a performance standard that our $20,000 chemical package barely matches?
The answer lies not in a secret mineral or a lost magic spell, but in a profound respect for passive physics and the most abundant resource on Earth, air. Modern insulation relies on chemical matrices to trap air. The medieval genius understood that if you could trap air simply, perfectly, and naturally, you didn't need the factory. They didn't need the polymers. They needed grass. The wattle and daub wall was a thermal sandwich. The outer layers of daub acted as the alligator skin, tough, durable, absorbing the sun's energy like a stone. But the inner layer was the true miracle. It was the breathing wood system, a sophisticated organic structure where millions of individual blades of grass, meticulously packed, acted as microscopic dividers, preventing the convective currents that steal heat. They created chambers of still air, the perfect insulator, using nothing but field cuttings. This sophisticated thermal design granted the medieval peasant something priceless: resilience. Their survival was not tied to a fragile grid, a fluctuating global market, or a constant energy flow. It was tied only to the enduring wisdom of their ancestors and the bounty of the land. In the next section, we will reveal the two critical steps to building this wall. We will show why failure to execute the second step would doom your family to freezing in a house built entirely of mud and straw. We begin with the foundation of the double wall.
We established that the peasant's secret to surviving -40-degree winters was not found in a furnace, but in the walls themselves. We established that their insulation rivals our own $20,000 packages. Now, let's dismantle the structure and understand the two critical steps that transform mud and sticks into a thermal fortress. Step 1. The foundation. Thermal mass and the daub sacrifice. The process begins with the frame, the wattle. Vertical staves, typically hazel or willow, driven into the ground or secured to the main timber frame. Thin, flexible withes are then meticulously woven between these staves. Think basket weaving applied to a house. This creates a panel that is flexible, stable, and surprisingly strong. Next comes the daub. The application of the mud mixture to this outer face is step 1. This wasn't just random dirt. It was carefully selected clay or soil, mixed with water, fibrous materials like straw for tensile strength, and often animal dung, which contains enzymes that aid in binding and increases elasticity, reducing cracking. Primary function of this first daub layer, the exterior layer, is weather resistance. It forms a protective skin, keeping the rain, snow, and wind out. But its secondary, often overlooked function is to act as the first element of the thermal mass. The thick earthen material of the daub possesses high thermal mass. During the day, when the sun is out, the daub absorbs heat, not quickly, but slowly and surely, storing that thermal energy deep within its structure. When the sun sets and temperatures plummet, this mass begins to release that stored heat back into the core of the wall. This is a crucial defense against rapid temperature fluctuation. However, the medieval builder understood a critical twist here. If you apply the daub to both sides of the wattle panel immediately, you create a standard single-wall house. This wall is weather-resistant, yes, but thermally, it's a failure in extreme cold. It possesses decent thermal mass, but the heat it stores is quickly lost through convection and conduction to the outside air. The true genius was recognizing that the outer layer, the sacrificial skin, was only half the job. To truly survive, you needed to create an impenetrable barrier against heat loss. This brings us to step 2. Step 2. The secret chamber, trapping the air guardian. The medieval builder did not daub the interior immediately. Instead, they built a second parallel wattle panel, a precise mirror image of the first, leaving a carefully calculated air gap. This gap, the secret chamber, was the key to their survival. The distance of the gap was not arbitrary. It was a scientific calculation dependent on the climate, wider in the north, narrower in the south. This gap was destined to be filled, but not with air itself, which would circulate and steal heat. It was filled with the most overlooked, most efficient insulator known to the ancient world: densely packed grass and straw.
Air, when trapped, is a phenomenal insulator. Its thermal conductivity is very low. The problem is keeping it still. If air can circulate, if convection currents can form, heat is rapidly transferred out in the way. The builders solved this by creating a grass matrix. The densely packed straw or dried grass, often 4 to 8 inches deep, created millions of tiny, microscopic air pockets. Each blade of grass acted as a physical divider, preventing air circulation and locking the air immobile within these minuscule chambers. The grass did not insulate. It created the still air chambers that did. This grass cavity was the guardian of the heat, and the small openings between the two wall panels, the imperfections and seams, were the gate for that guardian. This system created the perfect thermal barrier. The outer daub absorbed heat as thermal mass. The inner daub, applied later, absorbed heat as well. But the grass cavity provided the actual barrier, preventing heat transfer between the two layers. This combination allowed the walls to achieve insulation values that defied modern logic. Our modern chemical insulation relies on the same principle, trapping air. But we abandoned the free, renewable grass matrix for petroleum-derived foam and melted glass fibers. We replaced simplicity with industry. We replaced local wisdom with a global supply chain. The Bronze Age wall reminds us that the simplest solution, when applied with perfect understanding, is often the most technologically advanced. The medieval peasant had the superior technology as their default. We pay a fortune to barely match it. In the next section, we will analyze the philosophical implications of this choice. We will compare the medieval preference for efficiency against the modern obsession with convenience, and reveal why that single philosophical shift is the real reason modern homes fail when the power goes out.
We have meticulously dissected the wall. We have seen how free earth, water, and grass, organized by intelligent design, created a superior thermal barrier. But the ultimate failure of the modern world is not material, it is philosophical. We abandoned the Bronze Age standard not because it was bad technology, but because it didn't align with our emerging priorities. The clash is stark: medieval efficiency versus modern convenience. The cost of convenience. Consider the economics of your modern dwelling. Your natural gas furnace or electric heat pump runs constantly throughout the winter. It cycles on and off every hour, consuming energy, pumping power. Your monthly heating bills, even in a moderately cold climate, easily reach $400, $500, even $600. This financial burden flows directly into centralized utility companies, supporting a complex, fragile global infrastructure. This entire system prioritizes instant gratification. We want heat now at the flip of a switch. We have built an infrastructure requiring massive, constant energy input to maintain a seamless, unchanging level of comfort. Our homes are, in essence, giant, perpetually consuming machines. Now return to the peasants' double-walled structure. Their home was not a consumer, but a storehouse. Their system prioritized intelligent work. Building the wall was labor-intensive, yes. It required community effort, skill, and time. But once built, the system essentially ran itself on passive physics for centuries. The reward for that initial hard work was self-reliance and near-zero operational cost. They used wood for their masonry stove just once every few days. If they gathered the wood themselves, the cost was free, except for their own labor. They were utterly decoupled from the external pressures of a heating fuel market. The ancient philosophy was clear: work hard once, benefit for years, use thermal mass intelligently. The modern philosophy: pay constantly, rely completely, and accept that your comfort is dependent on the uninterrupted flow of a foreign substance. The wisdom of thermal mass. This philosophical difference extends beyond just the walls to the entire dwelling. The medieval builders possessed an innate understanding of thermal mass, the ability of dense materials like earth, stone, and thick wood to absorb and store heat energy. Your modern home, built with thin, dimensional lumber and drywall, has virtually no thermal mass.
It is engineered for rapid construction and low material cost. As soon as your modern furnace stops, the heat dissipates immediately. The house cools almost as fast as a tent. The medieval house, with its thick daub walls and immense log structure, functioned as a giant thermal battery. It absorbed the heat from the daily fire or the sunlight, storing it in the crystalline structure of the earth and wood. When the fire died, the mass released that stored heat slowly and steadily over many hours, often maintaining a comfortable interior temperature overnight. This mastery of thermal mass is what gave them their most precious commodity, resilience. The tragic irony of our push for progress has resulted in a deep structural vulnerability. We chose materials that were easier to manufacture, easier to ship, and quicker to assemble. We prioritized construction speed over thermal integrity. We assumed that technological advancement meant automatically abandoning the old ways. This regression was not limited to walls. Think about the medieval lanolin wool, a material that actually generates a small amount of heat when it gets wet, a feat modern chemical engineers still struggle to replicate. Think about the masonry stove that heats a home for 24 hours from a single 2-hour fire. We sacrificed resilience for convenience. We swapped self-reliance for infrastructure dependence. The Bronze Age wall reminds us that complexity is not sophistication. The most sophisticated solution is often the one that utilizes the most basic, local, and renewable resources with perfect, humble physics. The medieval peasant understood that true mastery of technology meant achieving maximum result with minimal external input. This is the enduring lesson. We have built a world that is fast, convenient, and fragile. The medieval peasant built a world that was slow, laborious, and impenetrable. When the global supply chain breaks down, which house would you rather be in? The one dependent on a constant flow of fuel and electricity, or the one that draws its warmth and protection directly from the enduring wisdom of the earth? In our final segment, we will summarize this profound choice and reveal the ultimate fate of this forgotten wisdom, concluding with the crucial lesson about our modern energy dependency.
We have seen the genius of the double-walled wattle and daub system, the wall that achieved modern thermal efficiency using only grass and mud. But the true power of the medieval age was not found in a single invention, but in the Architectural Trinity. 3 systems working in perfect harmony to conquer the cold. The wall was the defensive shield, but the shield needed a fortress, and the fortress needed a heart. The fortress, log cabins, and perfection of the seal. Consider the log cabin design. We think of log cabins as rustic, drafty constructions. The medieval cabin was an engineering marvel built for thermal mass and airtight integrity. They used logs 8 to 12 inches thick, enormous thermal mass. But the real secret was the notched corner. No nails, no pegs, just interlocking, precise cuts. As the logs dried and settled over time, they compressed into the notches, tightening the seal. Wood expands and contracts, and this precision allowed the seal to become almost perfectly airtight as the building aged. Your modern stick-built home is a collage of seams and thin materials, resulting in constant air infiltration and cold drafts. The medieval builder understood that every opening is a thermal liability. Their heavy thatch or sod roofs, often 2 feet thick, were a final, massive insulating layer. The cabin, built from local materials, stood as an impermeable fortress, requiring only periodic fuel addition, not constant consumption. The heart, masonry stoves, and the art of heat capture. If the wall was the shield and the cabin the fortress, the masonry stove was the heart. This was not the inefficient, smoke-filled hearth of early medieval history. This was a complex thermal machine. It was a massive structure built of stone, brick, or ceramic tile. The fire burned hot inside a small chamber, but the hot gases were not allowed to escape directly up the flue. Instead, they were forced through long, winding internal channels within the masonry structure. This forced path transferred nearly all the heat to the massive stone body.
By the time the smoke reached the exit, it was relatively cool, meaning almost all thermal energy had been successfully extracted and stored. The result? Build a hot fire for 2 to 3 hours. Close the damper, the massive stone mass continues to radiate warmth for 24 hours or more. One firing daily. Compare that to a modern furnace cycling on and off continuously, burning fuel continuously. The medieval system utilized the principle we forgot. Stone and ceramic store enormous heat. They designed a system to capture and hold every single available degree, respecting the energy captured instead of wasting it. The enduring lesson: resilience versus fragility. These three technologies, the wall, the cabin, and the stove, were not primitive. They represent a deep, sophisticated understanding of thermal dynamics, moisture management, and resource efficiency. Modern technology gave us convenience, but we paid for it with resilience. The medieval system didn't depend on global supply chains, power grids, or distant fossil fuels. It depended on local materials, passive physics, and human knowledge. These buildings worked for centuries. Many are still standing and still functional. How many modern homes will survive 500 years? How many will keep you alive if the power fails for a single week in the deep winter? The lesson here is not to abandon the modern world. It is to remember the principles we may desperately need again. As climate change brings more extreme weather, as our infrastructure strains, the stability we take for granted may not last. The true secret of the 3,400-year-old wall is not its material, but its philosophy of independence. The medieval peasant had a fundamental knowledge that their survival did not depend on complex, uncontrollable systems, but on their own skill and the ingenious application of the resources the earth willingly provided. We must remember what worked, what kept people alive for thousands of years before electricity, what worked in -40-degree winters with local materials, clever design, and the wisdom to use what is abundant, not what is manufactured. Which of these ingenious technologies surprised you the most? Which should modern society urgently rediscover to build a more resilient future? Drop a comment and let us know. If you enjoyed this journey into forgotten wisdom, hit like. Subscribe to Frost and Fire Lore for more deep dives into the practical genius of the past. Join me next time as we unravel the paradox of the medieval textile that gets warmer when it gets wet, and why modern scientists still struggle to replicate the peasant's mastery of the lanolin secret. Thank you for watching.